Welcome to the Walton Pi. Today we are going to be talking about the root test to determine the convergence of a series. So like the ratio test, the root test is used to determine if a series is absolutely convergent. So again, since all series that are absolutely convergent are also convergent, the root test will then be able to be used to show that some series are convergent. So if we have a series of the form n equals 1 to infinity of a sub n, then the root test is going to say that if the limit as n goes to infinity of the nth root of the absolute value of a sub n, if that is equal to some limit less than 1, the series is absolutely convergent. If we look at the limit as n goes to infinity of the nth root of the absolute value of a sub n, and that is a limit bigger than 1, then the series is divergent, and if the limit is equal to 1, then this test told us nothing. So if we have a series where it looks like taking the nth root of the terms is going to be useful in making a limit very easy to compute, then the root test will probably be definitive and give us a good way to answer it. But some problems, you don't necessarily want to be trying to take the nth root of it, and so that's why this is just one of several tests. I personally prefer the ratio test. I find it easier to use most of the time. But there are situations where the root test would be easier, so that's why we also have it. So the root test probably is going to work at the same times as the ratio test. So if we have the ratio test but the ratios are looking nasty but nth roots would be easier, then this is probably when we would want to use the root test. So let's do an example. Let's look at the sum from n equals 1 to infinity of 4n minus 3 over 2n plus 5 all raised to the 5n. If we take the nth root of the absolute value of the nth term, what we are left with is the limit as n goes to infinity of 4n minus 3 over 2n plus 5 raised to the 5th, which is 2 to the 5th, which is 32, which is bigger than 1. So because that is bigger than 1, that tells us that this series is divergent. If we do the limit if we have this other example, so the sum from n equals 1 to infinity of n squared minus 3n plus 7, negative 2n squared plus 6n plus 5 raised to the n. That is the limit as n goes to infinity of the nth root of the absolute value of n squared minus 3n plus 7 over negative 2n squared plus 6n plus 5. That's the limit as n goes to infinity of just the absolute value of n squared minus 3n plus 7 over negative 2n plus 6n plus 5. So that's going to be 1/2, which is less than 1. So that tells us that this series is absolutely convergent, and because it's absolutely convergent, the series itself is also going to be convergent. I hope this video was helpful. Please like and subscribe if you haven't already, and check out some of my other videos. I hope you all have a great rest of your day, and good luck with the rest of your math.